So let's start. So in the last class, we were talking about just a minute, please. So we were going through the methods and different members of the class, as we have discussed, like how to, you know, represent a real world object. We were trying to simulate it, its properties, behaviors, and all, right? Yes. So to that extent, we were able to succeed. Okay. So um, today we'll move ahead. We'll move further and we'll talk about the other things. Now we know how to represent an object and its properties and behaviors especially, right? So now we'll talk about another feature of object, that is polymorphism, normally which you see, which is a behavioral attribute, I can say, polymorphism, right? So an object existing in many forms, example we were talking about, um, an object, a person basically taking you know different roles, a person having different roles, right, and responsibilities. Yes. So water and all. Yes. So poly means here, as we have discussed, poly means many. Morphism means forms. Poly means many. Morphism means forms here, many forms. Yes. So now how do we implement this polymorphism in Java, and what will be the advantage? Okay, but before we move on any further, first of all, can you people tell me, was there any advantage of representing that object, the real world object, this way as a Java object? You see, we are defining the class methods and all, right? So did you see any kind of, uh, advantage of doing this? How it helps us in the application development? What do you people think? Yes, just let's try to understand what exactly happens here. Yes, like, when we talk about object, uh, and you see we are trying to create an object here, Java object. I'm saying, like, for that we need to define a class. In the class we got the properties. Properties are represented as fields and all. You got methods here, which represent the actions. So what did we achieve from this basically? So how it is going to help us in the applications? Yes. Okay. Reusing. Rupa says, like, okay, reusability. How you saying reusing or reusability? Could you please elaborate on this? So we need, for the other application or any other module, so we need to write code again. Okay.
So it helps in flexibility and maintainability, and it also helps to reuse the code, and we can inherit the code, and we can add extra more functionality into the subclass.
Okay. Yeah, but we are yet to see that inheritance and all. Fine. So yes, at this stage, I can say that yeah. You see, what we did is like now this object is a pack of everything which it needs. Basically, we got methods. Sorry, we got methods especially here. You see, we are putting the data and the code which operates on this data together, right? So we got everything related to a particular object here in one place. So, it helps us to store the data as well as process the data, right? So we can achieve these things here. So, you see, you got the methods and which basically helps us to manipulate that data related to this savings account. We are able to put everything together here, in a single unit. Yes. So that basically is called as encapsulation, which we'll see later. Yes. But as of now, you see, an object has got everything which it needs. You know, Here we use it to store the data as well as operate on it. We got methods to, manipulate the data which is stored in that objects. Right? We can manipulate the objects. I can say in other words. Yes. So this is what we have achieved so far. Now we'll see further what else we can do here and what will be the advantages. Okay, so of this design and all. Yes, we'll further try to explore these things. And Lokesh, hi, can you hear me? Are you familiar with Sham?
Hello. Hi.
Hi, Lokesh, are you familiar with Sham?
Hello.
You know Sham?
Yeah, Shyam, I know Shyam.
Yeah, so is he attending the classes or is he still on?
Yeah, he is. I think he's attending the classes.
Okay, so I don't see him regularly attending, so I just want to check. Okay, so just ask him
Okay.
to drop a mail, if possible. Uh,
Okay.
yes. Okay, fine. Thank you. So, thank you, Lokesh. So, now we got a lot of things to explore in the object-oriented concepts. Let's try to do that. So, as we have discussed, you know, yes, polymorphism. Now, let's see how this polymorphism is implemented here. So, for that, again, I would like to consider this example itself of savings account. Now, you see, we got withdraw method here. We have written some business logic in this, right? So this code which we have written in this method, as I told you people, it is business logic. So what do we mean by business logic? Yes, what does that means?
Which helps to implement the business rule that they are looking for.
Yes, the code which implements the business rules. You can say that. Yeah, the code which implements the business rules. Yes. So, okay, fine. Now you know what the rules which we have implemented here in this case. Um, you know, just checking for that balance, minimum balance. That's it. Whether there is sufficient funds or not. So, okay, this rule is appropriate if the customer wants to withdraw the amount from the branch, from a bank branch. Okay, so if the customer wants to withdraw from the branch, that's fine. So this rule applies. Okay, this rule is enough. And here, but you know that the customers can also withdraw the amount from ATM, right? Uh, Automated teller machines. So in that case, in case of the customer withdrawing the amount from the ATM, so what rules are needed? What will be the rules in that case? Just you will be doing this type of transactions, right? Withdrawing. What do you think? What will be the rules for that? Generally, what do you see? Yes. So we'll have PIN validation. Yes, PIN number. The user has to supply the PIN number. It should be a valid PIN number. And what are the other rules? Okay, here also we'll have minimum balance rule, of course. And what else? Checking for savings account. Let's say we are talking about savings account here. So we'll see that. And any other rule? Like you have maximum withdrawal amount here. So you see, the ATM machine, it cannot dispatch more than specified number of notes, for a particular currency designation. For suppose, if it is in India, especially the ATMs here, you got 1,000 rupee currency notes. If that is the case, then it can dispatch maximum of 40. That's it. Even any notes, I guess, maximum of 40. I'm sorry. It would be 40. That's it. Hundreds, 500s, and 1,000 designations. That's it. So 40, not more than 40. So maximum of 40,000, I can say here. That's it. Maximum of 40,000. So user cannot withdraw more than 40,000 per transaction here. Okay. Yes. So that is the rule. That has to be satisfied even. Yes. Users cannot, you know, withdraw more than 40,000. So let's consider these three rules. So now the application has to also provide the support for that now. So we have to implement that rules so that when user tries to withdraw the amount from the ATM, these rules will be validated or will be checked. Now what to do here? We need to support that withdrawal from the ATM as well. Now you see the withdraw method which you got here, it allows the users to withdraw from the branch, I can say. And now what we are supposed to do to implement that functionality for withdrawing or allowing the users to withdraw the amount from the ATM. So what we are supposed to do, can we implement that code in the same method here, or are we supposed to define another method here? So, you know, that functionality, I can say that it is better if we can implement it in another method. Okay. Yes. So that you see, whenever user tries to withdraw the amount from the ATM, so that particular method will be invoked and it will check for the rules. Okay. So it's better to have a separate method for that. So now let me implement this withdraw. Now what should be the input parameters for this method? Okay, it should take withdrawal amount, and what else is needed here? So pin, that is another mandatory, input value. So user should supply that withdrawal amount and pin. So account number will be read automatically from that card, right? From the card itself. When you swipe the card, so your details will be read. Yes. And basically one more thing. Here we got an object, and that object, especially every each object has got the data. So this method is going to operate on the data. That account number will be stored in that object here. Okay, we don't need to supply it again. We'll see that. So okay, fine. Now we have these two things: withdrawal amount and pin. So let's do this validations here. You see, if, sorry, here the pin number, we have it when we create an object. Basically, we'll store it in that object. So we'll have that pin, which is already stored. So this dot pin, which is actually in that object. So this dot pin means I'm referring to the pin number which is in that object, and we'll compare it with the pin number supplied by the user. We'll compare it with the pin number supplied by the user here. Okay. Yes. So if it is equal, okay, then we can further continue. Else we'll print an error message stating, okay, pin incorrect or invalid pin number, incorrect pin. Say that's it. Okay. So further we'll try to check for the maximum withdrawal amount. That rule we'll try to implement it. So if this, sorry, if withdrawal amount is less than or equal to 40,000, actually there can be a lot of rules which can be implemented here, but we are just taking only few rules here. Okay. Yes. Let's say less than or equal to 40,000. Else we'll print a message. Why I'm not doing it? There is a reason for that. Because you see, if we use a single condition, or if you use an if statement, then you won't know which condition failed. You got the point? Sometimes we have to be more specific while checking these conditions. Okay. How do you know which condition has failed? You got the point? Sorry. So we have to provide the details appropriately, right? If the pin number is wrong, okay, you have to check them separately itself here, so individually, so that we'll come to know where the problem is, or the application can accordingly ask the user to supply the details appropriately. You got it? Okay. So now let's say withdrawal limit exceeded, I can say. I'll print this message. Now we have implemented two rules now. So what is the third rule which you got here? So we have to check for the minimum balance now. The minimum balance in this case, you'll find that it is already implemented in this method. You see this method, in this method. Now previous method, we have implemented that minimum balance rule, right? So it checks for that minimum balance. Yes. So can we make use of that here? can we make use of that code or functionality which is written in that previous method in this method? So hope you got the point. Okay, what is it? Suppose we can make a maximum withdrawal amount within the second method. Maximum, I didn't get you, Neil.
I'm not entirely sure what you're asking. What do you like? We have a withdrawal amount that can be less than or equal to 40,000, and then I'm not entirely sure what you're trying to do with the second withdrawal method.
Yeah, you see,
I'm
we
not
are
sure.
making sure that the withdrawal amount doesn't exceed 40,000.
Okay.
Because, okay, if it is ATM, what happens is it can't dispatch more than that amount. Okay,
All right.
the number of nodes, as I told you people. So there will be a limit on that, right? ATM can't dispatch. So uh, you know that slot won't allow you to. That won't allow the ATM to dispatch more than specified number of nodes, currency nodes. So that is a maximum limit. Let's say if it is 1,000 rupees designation nodes, yeah, that is what I'm talking about. Okay,
Okay.
maybe in US also you may have such restriction. Yes, anywhere the machines they have that slot, right? The dispatch the where from where the more nodes are dispatched. So that slot will have that size which can't allow more than fixed number of nodes. That's it. Okay, so now hope you people got it. Now my question was here. Now we have to implement the third rule, right? So the third rule which we got here, that is checking for that minimum balance. Already we have implemented it in previous method, right? So you got the point. We have already implemented it in previous method here, the first method which I have defined yesterday. So now can we make use of that functionality, you see, which checks for that minimum balance in this withdraw method here? Can we do that? Yes, you can make use of that functionality. Okay, yes, you can do that. So what you have to do simply, you need to call that method here, withdraw of parcel withdraw amount. That's it. So what we are doing for checking for that minimum balance, so I'm calling that first method, the previous method here, which has got that functionality, so that I don't need to write it again. Yes. So is it clear for you people, all of you, what we did here? Now line number 39. Yes, can I have yes or no, please? Because I can't see your faces. I can't see your face, right? So understand, okay, whether you got it or not. So the only way I can, understand whether you people understood or not is just from your answers, yes or no. That's it. Okay, fine. Thank you. Yes. So that's it. So we have to now, you see, this way we can reuse that code also. That's good. Fine. Thank you. Thanks for your response. So now here, you know what? We got two methods with the same name. Have you noticed it? Is it possible to do this? I can say yes, it is possible to do that. provided the parameter types list is different. We can define more than one method with the same name in a class. Okay, in a class we can define more than one method with the same name, provided they got different set of parameter types. Okay, the parameter types list should be different. Yes. So, at this point I would like to uh, introduce you people to a small term which we use here called as method signature. So in Java, you got something called as method signature. Whenever we define methods in Java, you see we have defined a couple of methods in the class, right? So now what happens is here, Java will try to compare that methods, or not comparing in the sense it will check, it will try to, differentiate the methods here based on the method signature itself. How the Java will be able to differentiate or distinguish two methods here based on the method signature. So what exactly is this method signature here? Method signature means method name. It includes method name and the parameter types list. This is the method signature. Okay, parameter types list. Yes. So for example, if you consider this withdraw method, what is the method signature of this method? I can say that it is withdraw, that is method name, and parameter types list, only parameter types list here. Only the parameter types list here. Yes. So that is int, withdraw of int. That's it. Okay. Now what is the method signature of the second method? Can you people tell me? What is the method signature of the second method here? Yes. So it would be withdraw int comma int. That's right. Only parameter types are considered, not the names. Okay. We'll not consider the names, parameter names. Only parameter types are considered here. Yes. Okay. Now, until and unless, now you see, according to Java, these two methods are different because the method signatures are different here. Okay. So Java will not bother in this case. So it considers that these two are different methods because the method signatures are different here. You know what? Um, One more important point regarding the method signatures is, for suppose here, if I define a method this way, and let's say we got another method here, it's something like this, which with the return type, let's say we got some return type here. Okay, say float. So return this dot, or let's say just return set balance after the withdrawal, after withdrawing. Don't worry about that functionality which is defined in that method. Now I want you people to just consider this method names, parameter types and all. Fine. Now we got two methods here, right? So what do you people think? Are these two methods same or different? Are these two methods same or different? They're different. Okay. You know, for us, they might be different, but for Java, they are same. For us, okay. For we people, it might be different. Okay. But the thing is, for Java, they are same. So we draw off because it will go with method signature. Because it will go with method signature. So as I told you people, Java will distinguish the methods. Java will distinguish the methods based on method signature. Okay, please make a note of it. So how it will distinguish, how it understands that two methods are same or different based on that method signature itself. Yes. So in Java, I can say that method signature is used to distinguish the methods. Now, when you pass these two methods to Java, when Java reads these two methods, I can say that you know Java will treat these two methods as same because the method signature of these two methods is same. Yes. So can we define two methods with the same signature? What do you people think? Can we define two methods with the same signature? Just a minute, please. Hmm. Yeah. Hi. Can you people hear me? Sorry. I have to switch the connection. That's the reason why. It was just off for a while. Okay. So now let's do one thing. I'll just add this method to this class. And I had a question for you people. So can we do this? Can we define two methods with the same signature in the class? In a class, can we define two methods with the same signature? I can say no. We can't do that. Okay. Yes. We cannot define two methods with the same signature in Java. It is considered as method duplication. Okay. It is considered as method duplication here. Yes. You can't duplicate the methods. That is what the error is. You see, when I'm trying to do this, you got an error. Have you people noticed it? What it says? Duplicate method withdraw of int. You see, it shows that method signature here. Yes. So is it clear for you people? So this method signature, it plays a key role. It will distinguish the methods based on the method signature here. Yes. Okay. So now you see, let's come back to this part of this polymorphism here. Now Java, now it will check these two methods. Now it understands that the method signatures of these two methods are different. So it will allow us to define the method this way with the same name, but with different parameter types list here. Yes. You know what? This concept is actually called as method overloading. What is method overloading? Defining, okay, so method overloading is a concept of defining more than one method with the same name but with different parameter types list. Method overloading is a concept of defining more than one method in a class. Defining concept of defining more than one method in a class. It is also very important in a class with same name but with different parameter types list. Okay. Yes. So now what is the importance of doing this? Why we have to define the same name here? Why we have to define two methods with the same name? Can't we give a different name here for this method? Can't we use a different method for this withdraw method, for that second withdraw method which we got here? Yes. Yes, of course, you can give a different name for that method if you want. It is possible. You can give a different name for that method. It is possible. But you know, the reason why we are giving the same name to these two methods is that because they both got similar functionality here. First of all, the point is that these two methods, they both have got the similar functionality, right? These two methods have got similar functionality here. Yes, that is the first reason, because the methods have got similar functionality. So we'll give the same name for these two methods here. And the second reason, the second important point is that here, this approach makes this code user friendly as well. It is user friendly. Now you see, we don't have to bother about remembering the method names, because you see, if you give two different names for this method here, like two methods can have two different names. Now they will be different, right? Yes. Now you have to remember, okay, so which method performs which action. That means which method will withdraw the amount from the ATM, which method will withdraw the amount from the branch. Okay, that functionalities. Which method has got which functionality, that you need to remember again. So now we don't need to worry about it here, because both have got the same name. The only thing is you need to consider the parameters which you need to pass. Yes. So now, so if you call the withdraw method by passing one integer value, see, as of now we are passing one integer value here to call that method or to invoke that method. So what happens? So the withdraw method, you got two withdraw methods. The withdraw method which takes one integer value will be invoked. This one, withdrawal from the branch, will be invoked. And if I pass two integer values, for suppose here, I'll do this 1, 2, 3, 4. If I pass two integer values, this time the withdraw method which takes two parameters. There is the withdrawal method which has got the code or functionality to withdraw the amount from the ATM. That will be invoked here. That's it. So this method overloading concept which we got here in Java, basically this is how we implement polymorphism in Java, I can say, through method overloading itself. Through method overloading itself, we implement polymorphism. Okay, through the method overloading itself, we implement polymorphism, I can say. Yes. So how I can say that method overloading implements that polymorphism here? Now you see, we are able to define a method, you see, which is existing in two different forms, right? A method now it exists in two different forms. The functionality is also similar here. The functionality is also similar. So hope you people got it. Yes. So any questions in this regard, please let me know. Okay, fine. Now there is one important point which you need to understand. So whenever we have this type of methods, the same name with different parameter types list, that is when we are implementing this method overloading here, the compiler during the compile time, what it does is here, the compiler, it will check this method call. Okay, so this is a method call, right? So this method, in the method call, you see we got the method name and the parameters here. What are the parameters? We are passing two integer values here. These are not parameters, I'm sorry. The values which we pass, they are called as arguments. Please try to understand the difference. So people use these two terms, parameters and arguments, right? Actually there is a difference here. Parameters means, you see, while defining the method, you declare these variables, right? You declare these variables. These variables are called as parameters, and basically they hold the values which are passed on to this method. And the parameters, they also represent that input values, what input values the method takes. That is what is represented by the parameters, I can say. Okay. When we talk about arguments, they are nothing but the values which are passed on to the method while calling it. And you see these arguments which you pass, or the values which you pass, they will be stored into that parameters. Okay. Yes. So now the withdraw method, we are calling it by passing two arguments, two values, I can say. Now the compiler will check these two arguments. It understands that these two arguments are of type integer. So now the compiler will check whether there is any method whose name is withdraw and which takes two integer values. So if the compiler finds a method whose name is withdraw and which takes two integer values, what it does is here it will simply bind this method call to this method definition. It will bind that method call to that method definition here. Yes. So you see, this process of associating the method call to the method definition is called as method binding. Method binding. Method binding. So what is method binding or method resolution also? People use this term method resolution, but you'll hear this term a lot. Method binding itself a lot. Method resolution or method binding. So associating a method call to the method definition is called method binding. Okay. Yes. So it happens during the compile time, I can say. When it happens during the compile time, compiler will do this. Actually, why the compiler will associate that method call to the method definition? What do you people think? Why it does that? So that, yes, is anyone about to answer the question? Okay, I'll tell you people why the compiler does this. Here, the compiler will associate, no, why it is doing it. The question is why it does that. So that you see at runtime, for that particular method call, that method, the instructions defined in that method will execute. The instructions which are defined in that method definition, so that they will execute at runtime. You see, for that method call, which method has to execute? So it will be decided at compile time itself. So that quickly at runtime, okay, for this method call, that method definition will execute here. The instructions defined in that method will execute. That's it. Okay. Yes. You got the point, all of you? And it's done automatically. The compiler will do this. The binding takes place during the compile time, and compiler is responsible for this. So compiler should find an appropriate method for this. You see, for example, if I call a method, let's say without passing any parameters here. Now compiler, you see, uh, it will try to search for the method with the name withdraw, which doesn't take any parameters. So is there any method whose name is withdraw and which doesn't take any parameters in the class? In the savings account class, do we have such method? I can say no. And there is no such method. Yes. So in this case, what happens? You will find that the compiler is going to complain. You see, you'll get an error. So withdraw method withdraw of int in the type savings account is not applicable for the arguments. It says 0. Yes. So compiler here, it is checking for that withdraw method in which class. How it knows, like, it has to refer to that savings account class here. You see, the compiler, I can say that definitely it will look for that methods in the savings account class. But how the compiler will know that, okay, it has to look for that methods in the savings account class here? Yes. How the compiler will know that it has to look for that methods in the savings account class? Yes, that's right. You see, in order to call that method, we're using the object reference, right? Account. So this account reference is what type? Savings account class type. Based on that reference variable, it will come to know about the method, that class here. So that method, it has to look for that method in which class. Okay. So it will get those details through the reference itself. So this reference is what type? It belongs to which class? Savings account. So it will look for that method in the savings account class. That's it. Okay, so hope you understood the method binding. So you see, in method overloading concept, method binding plays a key role. So yeah, that itself decides, okay, for that method call, which method has to be invoked here. Then it is done at compile time. You see, because this method binding takes place at compile time, that means well before the program starts execution, right? Well before the program starts execution, or when this binding takes place. So that's the reason why this type of binding is called as early binding also. Early binding. People use this term early binding, or they also refer to it as static binding. Static binding means the program when it is not executing. So that is referred as static here. Yes. When the program is static, that means when the instructions in the program are not executed. That is referred to as static here. Okay. Yes. So early binding or static binding, we say. So any questions in this regard? Okay, good. So if it is clear, let's move on. So now we have gone through polymorphism here. There is how it is implemented in Java. You see, method overloading is one way of implementing polymorphism in Java. Also, you can make a note of it. Method overloading is one way of implementing polymorphism in Java. Okay, yes. You know, here, how can I say that this method overloading is a polymorphism concept here? Because you see, we got more than one method, a method existing in many forms, multiple forms. A method here existing in multiple forms here, right? Yes. So that is an example of polymorphism. Yes. Okay. Now polymorphism is also implemented using method overriding concept. We got something called as method overriding, but we'll talk about it later. Now, uh, the next topic which we'll be dealing with is method we'll be dealing with inheritance. In inheritance, we'll come across method overriding. Okay, yes. So in Java, I can say that we implement polymorphism using method overloading as well as method overriding. But method overriding is purely related to inheritance concept. So we'll see that after I introduce you people to inheritance. So now, what is the advantage of this polymorphism here? So I will show you some examples to make you people understand the advantage of polymorphism. Okay, yes. So for that, we'll refer to the Java docs here. Java docs means Java documentation, your API documentation, where you have the complete details about that API predefined classes and all. You know what is an API, right? Predefined classes in Java. You see, this is a site uh, from where you can get this API documentation. Okay, so this is standard edition 7 API specification. So what do we mean by standard edition here? Standard edition means your core Java. Okay, core Java. So you see, these are the list of packages which you got here. So one of the important packages is java.lang. So this is the fundamental package, I can say. So java.lang, it is actually known as fundamental package here. Okay, yes, the core package. So in this package, we got this interfaces. We'll see that interfaces. You see, these are the list of predefined classes here. And one of the classes here is string, which I would like to show you people now. Class called as string. You know, basically the string class objects, string is a class here. We use the string class objects to store text content. Text means set of characters, or we say string here in Java. Okay, so from now on, if you hear the term string, it means it is nothing but text content, set of characters. Yes, so for storing the text content or set of characters, we use string objects. We use string objects here. So now, this class is not only used to store the string content or text content, but it also provides the methods here to manipulate the content, to manipulate the text content, okay, which is stored in that object. It provides predefined methods. That is the advantage of API. You see, now you'll find that in the application development, there is a very common requirement for manipulating the strings. Manipulating strings is the most common thing which we'll be doing in the application development. So for that reason, you see, Java has provided a string class, and they have provided predefined methods in the string class. You see, these are all the list of methods defined in this class, and they provide, each method here provides a functionality that is related to manipulating the strings or operating on the strings, I can say. Now you just go through this methods here. These are the list of methods. You see, you can read that method names in middle. You got this method names. Now, can you people tell me which methods are overloaded here? Now, I don't want to explain the methods functionalities here. Just want to show you people how that overloading concept is used here. Uh, you know, uh, these are examples of overloading. Yes, which you can see in API. Yes. So which methods are overloaded here? Can you people tell me or identify the methods which are overloaded? Okay, no, int is a return type. This is return type. Don't see this first values here, the middle one. So content equals, you see this method is overloaded. Copy value of, yes, this method is overloaded. Yes, and format method is also, oh, sorry. Oh, lost it. Just a minute. Yes, you see, content equals, sorry, excuse me. Copy value of and format method. So these are all the methods which are overloaded. Now, can you people identify the methods which are overloaded here? Okay, index of, you see, index of method is overloaded. One, how many times? Two, three, and four. Four times it is overloaded. Last index of one, two, three, four times. Yes. You see, imagine, just imagine. Now you see, you got two methods, and overall, these two methods exist in 8 different forms. For suppose, imagine we have to give a separate name for each method, then what will be the issue? If separate name is given for each method, then what will be the issue? So yes, it would be difficult for us to remember the method names and all. So which method, implements which functionality. So that will be difficult again. Okay. Yes. That would be the problem here. Okay. Yes. And you see, we got one more method. This method is overloaded. Value of method is overloaded 8 times. Can you see this? It is overloaded 8 times here. Yes. So now here again the same thing.
Hello.
Yeah. You see. Yes. Any questions?
Yeah. Overloading means just when the parameters are repeated, that is overloading, no? Actually,
Not parameters are repeating here. Method name will be same. The
method name will be
parameter
same.
type
That is,
list will be different.
then here the parameter list is different in all the aspects.
Yes, that is what I said. You see,
Uh,
in the
no,
definition
that's what
also, in the definition.
overloading is.
Okay, please just read this once. What I said.
Yeah, method overloading is a
Concept
concept of.
of defining more than one method in a class, especially in a particular class, with the same
With the
name,
same.
but with different parameter types listed.
Okay.
It will
What I
be the
thought is
same.
the parameters.
No,
If
no.
the parameter,
If parameters are same, then it would be difficult. That won't be
it
possible
won't
to
access.
distinguish the methods and all, right? So
Okay.
that becomes duplication, method duplication. Yes.
Okay.
Yeah.
Thank you.
Yeah. Okay. So now you can find 8 methods. All that parameters list, of course, will be different for 8 methods here. You see, you can just go through that parameters types. For each method, it will be different. Yes. Now this value of method, again, all these 8 value of methods have got similar functionality here. They got similar functionality. So what they'll do is they'll try to this methods they take values, different types of values, and they will try to you know convert that value to string type. This method's functionality, it takes a value and converts it into string type here. That is the functionality of this method. Okay, that is what it does. Fine. So each method, okay, it converts a particular type of value to string type. Each method converts a particular type of value to string type here. That is what it does. Yes. Okay. So now just imagine, even here in this case, if you got 8 different methods with 8 different, sorry, if you got methods with 8 different names, that would be difficult to remember. So that is about overloading concept. Now let's move on. We'll talk about inheritance. So now this is one of the real world concepts, that this is one of the object oriented features here, so which we see in the objects. This is most common feature which you will find in the objects, inheritance. Even we people are big examples of inheritance here, right? So in general, inheritance is one object inheriting the properties and behaviors of another object here. An object inheriting the properties and behaviors of another object. Yes, that is what inheritance is. So, but now, how do we implement this concept, inheritance concept in Java? How do we implement the concept of inheritance in Java? Yes. So, I'll just write it down here first of all, and then we'll see. In Java, when it comes to programming, let's see how the inheritance concept is implemented. We can use inheritance concept to define a new class by deriving the members of an existing class, I can say. Inheritance is a concept of, when it comes to programming, I'm talking about it, the concept of defining a new class by deriving the members of an existing class. When I say members, what does that mean? Members of a class.
Methods and
It can be variables and methods, both, as we have discussed in the last class. As I told you people, when I say members of a class, that means they can be both static and non-static, and especially members means they are nothing but variables and methods. So we can create a new class by deriving the members of an existing class. That is inheritance here in the programming. So for this inheritance concept here, again we'll consider the savings account class itself. Okay, I'll tell you why. So for suppose here, let's say you have been given a requirement. You're given a requirement. So now you got a task here. What is it? You need to define a class that class, it should represent junior savings account objects. Junior savings account objects. So in a bank, you will find that yes, banks will offer savings account for kids or children also. We call them as junior savings account, let's say. Bank is offering savings accounts for kids. Okay. So now we need to define a class to represent the junior savings account objects here. So how will you start? Now you should tell me. So this is the time. Now you can just start applying whatever you understood so far. Yes. How will you start? First of all, if you are supposed to define a class, what you are supposed to do? If you are supposed to define a class for an object, so how will you start?
Public class, junior saving account.
Okay. But
Then
first of all, I can say that you have to identify, don't worry about inheritance here, okay? Don't worry about inheritance. You have to identify the properties and behaviors of that object, because the properties we will represent them as variables and methods and behaviors as methods. Now, in a class, what variables you'll declare, what methods you'll define. So that depends upon the properties and behaviors itself, right? So all of you please remember, fix this in your minds. Whenever you're supposed to define a class for an object, first of all identify the properties and behaviors of that object. Okay, so what are the properties and behaviors of this object now?
account number, balance, then
Okay, um, yes, account number, you'll have account number for junior savings account, you'll have balance, yes, you'll have PIN, let's say you'll have branch code, yes, everything. And especially you'll have a guardian for this account, because it's a kid's account, a guardian will be there. Let's say guardian name, fine. The behaviors would be, actually there are so many properties, but just for our convenience sake we'll just consider a few properties. Yeah, now when we talk about the behaviors, you'll find withdraw, deposit, transfer of funds, everything, right? Yes. So now we are done identifying the properties and behaviors of that class. So what's next? Now we need to define a class. Okay, but before we define a class here, so we can, now in this case, yes, what we can analyze one thing. I can say that we can analyze one thing. We already got a class here which represents the properties and behaviors which we got here for this junior savings account object. Already there is a class. Okay, in that class you got the variables and methods which represent the properties and behaviors which you got for this junior savings account object. Okay, but there's one property which you don't see in that savings account object, is guardian name, right? Yes, you won't find it, the guardian name. Yes. So now the question is here, so can we make use of that class, that variables which are already declared in that class, the methods which are defined in that class here, to define this new class here? Yes, you can do that. Already we got the code which represents the properties and behaviors, right? Yes. So why don't we make use of that code which is already existing instead of developing it from the scratch? Of course, we can do that. Okay. So that is where the inheritance comes into the picture. Now what you can do is here, we can define a class. Let's define a class. let's say the class name is junior savings account. Okay, now I would like to derive the members of that savings account here into the junior savings account class. So that means we would like to inherit the members of that savings account. For that, you have to do this. Use extends keyword, extends savings account, extends savings account. So now this indicates that here the junior savings account wants to derive or inherit the members of savings account class. It wants to inherit or derive the members of savings account class here. That's it. So is it clear for you people? Okay. Now one property, it is not represented in the savings account classes. Yes, I'm coming to that point. That's right. So guardian name is not available in the savings account class, right? So that property, now we can declare it as a field here in the junior savings account class. You see, this is very much specific to the junior savings account class. So I'll define it here itself. Guardian name, sorry, guardian name. So I'll declare it as string type. String is used to store set of characters. It's not primitive data type, so we didn't discuss about it at that time. But we'll see this applications now. Okay, don't worry. So this property, you see, now you see you may have some additional properties here uh, related to this particular object itself, which are very much specific to this object. So you have to declare that variables accordingly here in this class. That's it. Okay, fine. So now I can say that in this class we got 4 fields, especially non-static fields. 4 fields are there. What are they? Account number, balance, PIN, and guardian name. So, but we didn't declare account number, balance, and PIN here in this class, right? But it is inheriting from the superclass here. It inherits it from the superclass. And can I say that in the junior savings account class we got withdraw method, deposit method? Can I say that in the junior savings account class we got withdraw method, deposit method, and all? Yes, of course, you can.
Yes.
So we can say that. Now let's test this. Actually, you know what here? The junior savings account class is deriving or inheriting the members of that savings account class using this extends here, I can say. Now this junior savings account class is called as a child class, or you can call it as a subclass, or you can call it as a derived class. Okay, you can call the junior savings account class a child class or a subclass or a derived class. Whereas the savings account class here, the members of this class are inherited by another class. Now this class becomes the parent class, or you can call it as a base class, or you can call it as a super class here. So all these names means the same. Okay, parent class, base class, super class, all means the same here. Yes. So is it clear for you people, all of you? So now let's test this code. So let me show you people here how it works. Now I can instantiate the junior savings account class to store the junior savings account details. So I can do this account number. You see, now you will be able to access that account number variable, that instance variable, as if it is declared in the junior savings account class. You see, I'm able to use that account reference variable here, which is of type junior savings account. I'm able to use that subclass reference to access that savings account variables here. Yes. Okay. Similarly, account number dot balance, say 5,000, and guardian name, let's say some name Harry. Let's say account dot pin. That's it. So I'm using subclass object reference to access that fields of variables which are declared in the superclass. Okay, fine. And now you can also call that method. It works. So you can call withdraw method. Okay. Yes, definitely it works. That's it. So I'm not printing anything here. You see, if there is any error, you'll get a cross mark. Fine. So this should definitely work for us. So let me just try to print these details. So we'll print that guardian name, account dot guardian name. Okay. So let me run this code. Yes, it works. Sorry, just give me 1 minute, please. Just a minute. Sorry. So now you see here we are able to access this variables and methods using the junior savings account object reference only because this class is inheriting that savings account class. What if the junior savings account class is not extending the savings account class here? So what if this is the case? So this is just a Java a class, that's it. The entity is not inheriting any other class. So in that case, let's see, you'll find that you got errors now. So it says account number cannot be resolved or is not a field here. It is not a field here. Yes. So the withdraw method which you got account.withdraw is undefined. So now it won't work. Earlier it was inheriting. No, it's not inheriting. So it is not going to work. Yes. Hope you people got it. Fine. Okay. Now you see how we are initializing the object. In Java, how do we initialize the objects? What is the recommended approach? How do we initialize the objects?
by using constructor.
So using the constructor, right? So, but now when we got inheritance in place, so how will you use constructor here to initialize the object? So that you people need to understand. Okay. So when we got inheritance in place, what to do? So why particularly I'm stressing on this point when we got inheritance in place? Because you see, when we got inheritance here, you'll find that a few properties, a few fields, I'm sorry, few fields, they are declared in the superclass and few fields, they are declared in the subclass, right? Yeah. Few fields are declared in the superclass and few fields are declared in the subclass. That will be an issue here. So how it is an issue? Yes. Because you have two different classes, the variables are defined in two different classes here. Okay, now we'll try to use a very simple approach here which helps us in this regard. Okay, let's see what is it. Just a second. Okay, fine. um, is my voice clear for you people? Any issues? Okay, thank you. Now, you know, um, when we talk about initializing the object using the constructors, you will find that already we got a constructor in the superclass which can initialize the superclass fields here. We got a constructor in the superclass which can initialize that fields related to the superclass. So the question is here, can we make use of that superclass constructor? Can we make use of the superclass constructor here in the subclass to initialize that superclass fields so that we don't need to write the code again? Already the constructor is declared, right? So can we make use of that constructor? Now the question is here, okay, when we talk about making use of that constructor, so we'll think about one thing immediately. Um, does the subclass or can the subclass inherit a superclass constructor? The subclass, will it be able to inherit superclass constructor? A subclass, can a subclass inherit superclass constructor?
No.
Yes, that's right. You know what? A subclass cannot inherit the superclass
Yeah.
constructor here. It is not possible.
Yeah. So whenever the object is created, it call the subclass constructor first, and then the subclass constructor call the superclass constructor and follow up the hierarchy.
Okay. Yes. You know, a subclass cannot inherit or will not inherit a subclass, a superclass constructor here. But you know what? Yes, a subclass can call the superclass constructor. A constructor can be called from anywhere. You can invoke it from anywhere. From the subclass also, you can call a superclass constructor. So here, though though the subclass cannot inherit that superclass constructor, but it will be able to call the superclass constructor here. It will be able to invoke that superclass constructor. So now keeping in that mind, let's try to define a constructor in the subclass such a way that it calls the superclass constructor to initialize that superclass fields. Now, if you're using Eclipse IDE, it won't be a big deal. Okay, let's see. Now, one more thing which you need to remember here is that we got a variable in the subclass as well here. We got a variable in the subclass as well. Yes. Okay. So we need to also initialize this variable. So subclass variable will be initialized in subclass itself. Okay. So now all of you, please make a note of this. Defining a constructor when we got inheritance in place. Defining a constructor when we got inheritance in place. Okay. Yes. So now you see in the Eclipse IDE, you can just do this. Right click on the class, make sure that the cursor is in the class, make sure that the cursor is in the class, and then right click on it. Once you do that, you see you got the source option here, right? Select the source option. And the source option, sorry, in the source option, so you should say generate constructor using fields. Generate constructor using fields. Use this option itself. Okay. We have already used it earlier. Now also we'll use it, but there will be a slight difference, I'll tell you. So generate constructor using fields here. Yes. Did you people make a note of it? I hope so, right? So I'll just select this option. So right click on the class, or sorry, right click and make sure that the cursor is on in the class and right click. Then select source option. Under the source, you have generate constructor using fields. So now I'll select this option. So once I select that option, you'll get a pop-up window here. You'll get a pop-up window. See, now the first option which you got here, it says select a super constructor to be invoked. Now in the drop-down list, you'll find two calls here, a default constructor and a parameterized constructor. Now select the parameterized constructor. Call to the parameterized constructor is there. Now just do this. Select the parameterized constructor of the superclass. And you see down you got the fields. It says select fields to initialize in the class. What fields you got? Guardian name. We'll try to initialize this field. It is already checked. Okay. So first on top, make sure that you select the parameterized constructor of the superclass here. Okay. Now you can click on OK. So once you do this here, you'll find that you got a constructor. It's a parameterized constructor. And how many parameters we got for this constructor here? How many parameters we got for this constructor?
Or
We got 4 parameters. Yes, we got 4 parameters. You see the first 3 parameters, account number, balance and PIN. Now these 3 parameters will hold the values which will be used to initialize the superclass fields. The first 3 parameters will be used to initialize the superclass fields. And you know, here the last field, that parameter, last parameter, it holds a value to initialize the subclass field. Yeah, yes, yes. So now this constructor, the subclass constructor, is its junior savings account class constructor. So what it is doing here in the constructor, you got this statement, you know, super. Super is used to refer to the superclass. I can say that it is calling the superclass constructor here. It is actually calling the superclass constructor. And here, see, when it is calling the superclass constructor, it is also passing the parameters here to the superclass constructor. It is also passing the parameters to the superclass constructor here. Yes. So now the superclass constructor will be invoked. So it will take that values that values which are stored in that parameters, they are passed on to this constructor, superclass constructor, right? It will initialize the superclass fields. And once it is done initializing the superclass fields, again the control will come to the subclass constructor, which in turn initializes the subclass field here. That's it. This way, both the superclass and subclass fields are initialized here. That's it. So, super is used to call the superclass constructor. This is how from the subclass you'll call a superclass constructor here. Now let's make use of this constructor here, that parameterized constructor which you got. Okay, I'll do this. Fine. So now we are passing 4 parameters here. That's it. Now that constructor will be invoked, parameterized constructor or the subclass. Now that values are passed into are stored into this parameters, right? The subclass constructor is invoked. The values are stored in this parameters, and that values which are stored in the parameters, in turn we are passing them to the superclass by calling the superclass constructor here. Okay, and then we are initializing the subclass field as well. That's it. Okay, so let me run this code. Yes, it works. Now, what is the advantage you see here for the inheritance? Now we saw this inheritance, right? So not to full extent, yes, to some extent we saw inheritance. Now what do you people think? What advantage do you people see here? Okay, easier to write. That is one answer which I got here. What else? What advantages you see here?
We can inherit.
Yeah, tell me.
So we can inherit the more general like behavior and can implement more specific behavior in specific subclass.
Okay, we can implement more specific behaviors in the subclass. Okay,
And we
okay,
can
that's also a
use
point.
the reuse the code.
Reusability.
Yeah.
So one of the most important advantages of inheritance concept is reusability. Sorry. So reusability. So able to reuse the code, existing code. Reusability. reusability. So see how the real world concepts, when they are applied in the programming, are giving us the benefits. Yes. Yes. That means we are avoiding code duplication. Duplication of the code is avoided here, right? So we are able to use the existing code which is already defined or which is already written, here. Yes. So hope you people got it. Whatever we have done so far. Is this clear for everyone, or anyone got any issues in this regard? Please let me know. Okay, good. Anyone got any questions? Yes, I'm waiting. Think about it. No worries. Don't be in a hurry.
Are we using this polymorphism and inheritance in the same program?
Um, okay, there is a question. So, are we using inheritance and polymorphism in the same program? So, okay, let me ask others also. What do you people think? Are we doing that here? So, are we using polymorphism and inheritance in the same program? Okay, Neil, I guess, Neil, are you thinking? Okay, sure, you can. Two answers as no. Okay, inheritance, yes, because of extension, okay. So how about polymorphism? I can say yes. We are doing both. You see the subclass, don't you think the subclass is inheriting these two methods which are implemented based on that polymorphism concept, which are based on the method overloading? The subclass, isn't it inheriting these methods? So the subclass is based on inheritance. Okay, it uses inheritance concept, of course, and it is also inheriting those methods, overloaded methods, which are based on polymorphism. That means we got both inheritance and polymorphism here, right? Hope everyone got it. Yes. And I guess you have answered your question. Was it Veena? Yes.
Yeah.
Okay. Hope you people got it. Yes. Fine. So any other questions? Okay, fine. So I would be adding some exercises also. What about the exercise which I gave you people in the last class? I've asked you people to implement a circle object, define a class for circle object, right? Yes, that is what I'm planning. So we'll do it in the Dropbox. Fine. So, but whatever the tasks they gave you, people try to. Okay, fine.
Um,
Yeah. Any question?
no, Mahesh.
Okay, fine. So as I told you, people, I'll be taking a an extended hour session today. But I'm sorry. Today, I'm sorry. I've got uh, some issue here. So the thing is, okay, today is a festival. My elder sister, she just she came. Uh, okay, so she's late today because of some other issues. So I have to receive her, and I got some stuff to do now. Surely personal. Sorry for that, but I'll extend the class, over the weekdays. Someday, couple of days, I'll take your concern before I extend the class timings, and I'll definitely do that. But I will make sure that this won't repeat for the next week. Okay? Yes. So just please excuse me only for this week. Okay? Uh, but next week we'll definitely do this. Okay, long session. Fine. So hope you got me. We'll try to meet again on Monday at our regular time itself. And I got a question. What is it? I've been working on the assignment but could not get that whole thing done. So I will complete and send the file. Okay, sure, sure, you can do that. And once your people are done, just mail me. And let me just try to. Could someone has to mute the mic, please? It's going wrong. Okay, so I'll also fix a time for you people. Um every day after the session, you can just stay back if you got any questions or if you got any issues and just get it resolved. I'll let you know the time, prior time. So today it's not possible, but from Monday we can do that. Okay? Yes, fine. So any questions, please let me know. Okay, good. Sorry for that today. Sorry. So I could have spent some more time. But the thing is, I got guests just because today's festival. So my elder sister, she just came late today, so she used to be early every time. Sorry for that. Okay, so let's meet again on Monday, and let's continue our
Mahesh,
discussion.
do you we have assignment for today or not?
I'll mail you. Okay, I'm going to add it to the Dropbox.
Okay. And one more thing, you are from India. You are now in India or in US?
I'm in India, Hyderabad.
Okay. Actually, I was trying to call you and I couldn't.
Actually, you cannot add me to your WhatsApp. Okay, you can for
Mm-hmm.
instant messaging, and we can, you can ping me whenever I'm free. You can call me. Okay. Yes, this is my number. I'm in India. Okay, I'm in Hyderabad. Yeah. Okay. Fine.
Okay, thank you.
Okay, then this is my number. You can take it. Everyone. So when if you for instant messaging, you can use this. Okay. Yeah. Okay then. Thank you all. Enjoy your weekend. So let's just look for just refer to the Dropbox once for any assignments which I'll be posting. Probably I'll do it tomorrow. Okay. Yeah. Thank you all. Bye bye.